Welcome to KU Pathshala. I'm actually going to give a small talk on myths and realities about space. This is a module in my Moodle course offered by me called Space Age Materials and Technologies. This is there on the university LMS platform. This talk basically emanates from my experience with school students and college students who often ask questions, which actually makes me ponder about how illiterate we literally are about space. So I will start off with the most talked about question that every student asks about space. Are we alone in space? As on today, the answer to it is we are alone. Today, we don't have any evidence of any other life form anywhere in space. So, this is based on our knowledge of today. There are very famous mathematical models which are often used to predict the possibility of finding extraterrestrial intelligence. See, when we say extraterrestrial intelligence, we mean of a life form which can be very different from our own form. We are specifically based on, say, the hydrocarbon systems like carbon, hydrogen, oxygen, nitrogen systems. But we can also have a life form which doesn't work on this. But see, science that we know today, which is applicable on Earth, will be the same science on any other planet. You will not be able to say that gravity works only on Earth and gravity will not work on, say, a planet which you discover around 4.5 billion light years from here. So whatever is the rules of science that we have laid down on Earth today will be applicable on any other planet that we discover. And hence, whatever is the system that we follow or scientifically explain a phenomenon will be the same phenomenon on any other planet. Hence, the general answer is that as of today, we have not discovered life on any other planet. We are alone. We are searching for someone out there. There are, as I said earlier, you can actually put a mathematical formula, because say we always say of a probability, right? When you toss a coin, there's always a probability of finding a head and finding a tail, and we say that you add the probability of finding a head and finding the and the probability of getting a head and tail, you add them, you get a probability of 1. That is, there will be always a possibility that you will either get a head or a tail. In the same way, a mathematical model can be put forward based on today's knowledge that we have, say, discovered or identified around 4.5 billion stars, and in among these 4.5 billion stars, as of today, we know that we have life only on one planet. So that is basically a very famous equation which actually predicts the possibility of finding life on another planet, and it works out to be greater than 1 actually. So we are hopeful based on that we may discover or we may come across a life on some other planet. Let's wait. So this is one common question that often I'm asked by students, that do we have life on any other planet, or is there the probability of finding a life on any other planet? The second most interesting question that I often ask students is, we'll start off with the image of our galaxy that we actually see. See, there's an image that we all see, right? One is you see a spiral, the other one is you see a flat one. And you can also see in the presentation behind me that you can also see a very different image. It's a image which is actually taken using infrared radiations. The other two images which we commonly see is based on, say, visible radiations or visible light which our eye is able to sense. You can also have an image which is based on infrared radiations which your eye can't pick. Now, the question that I often ask my students is that who or which satellite took this particular image, because so if you look at the image, you have to have a camera which actually takes this image, right? So students always come up with a number of names, everything that they know, from Kepler to Hubble. But the fact is that even this image is actually a construction. It is only a construction. So when I say it is a construction, I personally feel that the image will change in, say, 100 years from now. As technology matures, we will definitely find a different image of how our galaxy is. Now, if you ask me, we can argue on that, but typically remember that this image is actually only a construction which is based on recording images at 360-degree around us. See, you keep a camera, the camera is looking into space, and you keep all 360-degree around us. You take this image and put them all together, and how it will appear is what you are actually seeing. Because see, everywhere in space everything is uniform. So this is what we assume. So if you put a camera and take a photo every 1 degree, so you get 360 images, and you club together all these 360 images into a single plane. This is what is the image that comes out to be. And the other question that we would have to ask is, so we are sitting in our galaxy. You have to think about say a day when a satellite actually goes out of the galaxy and takes a picture of the galaxy. See, it's a simple thing. Like, you stand in front of me, you take a photo, you're going to see my face. You go behind me and take a photo, you would see the back of my head. So it's the same concept. So maybe in, say, 100 to 200 years from now, if at all we have a developed technology, the image will actually change, is what we anticipate. So this is what I just wanted to prove or say at this particular point of time, is that the image that we say as our galaxy is actually a constructed image based on the available technology with us. So when our technology changes, this image is bound to change. And all these colors that you see in these are based on the sensors that are used to sense a particular color. Because some of the planets may have their own colors, but all these images that we give is just to understand the light which is coming in. So from that comes the next question, which is very common. I often ask my students, even at degree students or even PG students, have a confusion on what is the color of the sun actually. Because if you take the Google and give a search on what is the color of the sun, you will end up with a number of answers there. So actually the correct way of looking at how to answer this question would be, put yourself on moon and look at the sun. What would be the color of the sun? You put yourself on earth and look at the sun. What is the color of the sun? So it shouldn't change. That is the question actually. See, as I said earlier, whatever is your theory, it should work out in every planet that you put your feet onto. So the correct answer is actually the sun is white in color, but you are able to see it in yellow color, and you will be able to see it in red color. And you would be surprised to say that maybe when you go to the planet Neptune, if you go to the planet Jupiter, you will actually see a blue color sun there. During the sunset, actually, during sunset, the Jupiter moon is blue in color. So it varies. So, but the ideal answer or the exact answer is that the sun is white in color. You can see it in different colors based on the atmosphere which is surrounding us. So when the atmosphere changes, the color will change. That is why in Jupiter, the sunset is actually, you will see it blue in color. So this is one common question which actually I also confuse students by asking different questions on what the color is. And typically all of us will say about different colors. So this was the other common question. Now, one of the most interesting questions that I often face, even from very senior people, and I think a lot of some of the people have also lost money because they didn't know the answer to this question, is can you buy a piece of land on moon? There is actually, you can actually, if you go to the internet, there is a website which actually sells land on moon. Now the question is, can you own a piece of land on moon? The question is, yes, you can own, but again the answer is, who will give you the ownership? Because say if you live in, say for example, I live in Kerala right now, so it is the government of Kerala which says that I can own a 1 or 2 or 3 or 5 cents of land, the government of Kerala would give me a certificate saying, okay, you own this piece of land, you have to pay tax. But on moon, who owns moon actually? So nobody owns the moon, and hence all of us have equal right on moon technically. Provided one day we all can go to moon, we can put a boundary and say this is my land, this is my piece of land, and still who will be governing moon to say that okay, you can own that piece of land? So the basic answer is that globally all the governments in our earth, all the governments on earth have agreed that none of us can own any piece of land out of earth. So the moon is yours, moon is mine, all of us have equal rights on moon, earth, on moon, on the sun, on the Jupiter, on Neptune, any planet that you discover. This is all, it's a legal framework. So don't put your money or don't waste your money by buying a piece of land on moon and saying that you own a piece of land. So this, I think this was one of the biggest hoaxes. There's a lot of cases also going on this issue, on how you can own a piece of land out of the space. So even if somebody gives you a document saying that this is your own, yeah, you can have the document, but it is not legally valid. When we talk about even legal validity, who gives you the validity? That is a question which arises. So maybe say from 100 years or 200 years from now, all of us have rockets on which you can go to moon and come back, and then maybe moon is governed by a government there. Maybe then you can say, okay, moon, you can have some ownership. Say the same maybe for Mars. But quoting right now, you say that none of us or nobody can own any piece of land out of earth right now. This is one, I think, a lot of questions which commonly come. And one simple question that I often ask students is that, how high can a balloon go? Say you take a balloon, you fill it with hydrogen, you release it, how high can a balloon go? Because basically I think I saw on the internet one of the a Hawks video saying that somebody went into the outer space. He took a photo from space and jumped from space. So how did he go to the space? The question is, he used a balloon to go to space. So that is why actually I thought the question is, how high can a balloon actually go into space? So the question is, how can a balloon go into space? That is the first question that we could think about. Now you blow air into your piece of balloon and leave it, it is not going to go up. So the idea is basically from the Archimedes principle, which says that there has to be a change in density which allows the balloon to actually move upwards. And it will stop moving upwards when the air pressure inside the balloon equals the density of air inside the balloon equals the density outside it. So just to get that equilibrium, the balloon can keep going upwards. So to attain that, what we normally do is you can fill it with hydrogen or helium, which allows the balloon to go up. Now as the balloon goes up, we know that the air density actually decreases as you go upwards, and hence a balloon will be able to move up to a point where the density of the air becomes equal to the density of the hydrogen gas, and beyond that it will not go, it will stay there, and then because of heating it would burst. So the record as of today is around 53 kilometers is the highest point that a balloon has actually moved. That is basically sent from one of the Chinese laboratories. They have their record. But a typical balloon, that is say a normal hydrogen balloon that you can get from the market, it can go up to a maximum of only around 10 kilometers, beyond which it actually blasts off. So this is the other, so I think that answers a lot of questions about anybody sitting on a moon and going to the space and then jumping off the space to come down. Now another question, I think what I would like to take up is, where is the edge of the universe? This is the other question that has so many answers and so many arguments that we have to put forward. Now when we talk about the edge of the universe, we will have to think about, we believe about the Big Bang theory. So to start off the answer, I will say that let us place ourselves on the beach and look at the ocean. Now, when we stand in the beach and look at the end of the ocean, you can see the end, right? But is that the end? No. We can see only up to the horizon there. But the ocean is there again, because the earth is curved, you have the ocean again. It is the same thing. So, when we look into space, what are we seeing? What we claim to be the edge is the point from which light is actually capable of reaching us. So, again the question again comes is, from where is this light coming? Say typically 4.5 billion light years, or around we have say around 1.75 billion light year light is what we are actually receiving right now. So, there is light before that also. So, all that light, if we are able to see, we would be able to see beyond the edge that we see today. So, two questions actually, or two riddles that come about is, does the universe itself have an edge, or what are we seeing? So, the answer is, what we are seeing is the edge based on the light which we are receiving from that particular edge, and beyond that edge again the light has not been able to travel and reach us, and hence we are not able to see it. So, where is the edge of the universe? If you ask me, we have not seen the edge. That is the actual answer. And is there an edge? If you ask me, that's again a contradiction, because we have two theories. One which says that the earth, universe is expanding. Now, if you say that the universe is expanding, see, if you say that something is expanding, there should be something into which it expands, which means that if you say this is expanding, it is basically expanding because it has something else outside to expand to. So, if you say the universe is expanding, where is it expanding to? And the other thing is that if you say that the universe is contracting, which means you should be able to see the edge which is coming inwards, that also we do not see. So, these two questions actually a lot of theories do come in, but as of today, let us say the answer is, what we see is based on the amount of light that we are receiving from the edge of say around 1.75 billion light years. Beyond that, there is space out there from which light is not receiving to us, and we do not know what it is. So, this I think that clears to an extent the question, what is or where is the edge of the universe. The other question that I would like to take from my students is, can an astronaut sitting in the space station see the earth rotating? Because I think the internet is full of images showing the earth rotating. So, the typical question is, if you think that you are an astronaut, you are sitting inside this space station and you look down, can you see the earth rotating about its axis? The answer is no, basically because it takes 24 hours for the earth to rotate about its own axis. So, a astronaut who is sitting in this on the satellite, if it is a geostationary satellite, is actually moving along with the earth, and if it is actually not a geostationary satellite, what happens is the earth is rotating at a very small rate at which he would not be able to see the rotation at all. Like, see, when you sit on the earth, do you actually see the earth rotating? We do not see the same effect. So, the question is, no, an astronaut sitting on a satellite will not be able to see the earth rotate. And then you have a lot of videos which show that the earth is rotating. Again, as I said in my first answer, it is again an image reconstruction. You have to say you record for 24 hours, you put it into fast forward, so that 24 hours of recording comes into say 1 minute. So, you would feel that the earth is rotating. So, this is all is image processing, which is done using video editing softwares. So, that is the answer to the question, that is, can you actually see, can an astronaut see the satellite rotating? Another question is, I think we should normally, any child actually asks, what will be the smell of space? That is again a very interesting question, because think about somebody who goes into outer space and wants to take a puff of the space out there. So what would be the smell of the space? So this is again this is actually a debated question, because there are a lot of answers to it. If you look at the image in my backup here, I think I have not taken that image here. Yeah, what is the space? Yeah, if you look at this, see, if you some of the asteroids, if you do a composition analysis of these asteroids, you can find out some components. If you go to the moon, you can actually you will find it to be silicon dioxide. So each of these have their own smell. So, but the question is, what is the smell of space? And astronauts who have gone into space claim that they have smelt of say cheese, of gunpowder. So it actually strikes basically because we think that yes, there was a big bang, there was a big blast, and maybe that smell of the blast is there. But let us think from the original perspective. Actually, space is vacuum. Vacuum means there is nothing. So there is no there is nothing there, and when there is nothing, you cannot smell nothing. That is a fundamental thing. But the other perspective of actually how you actually perceive a smell is, see, we have vacuum systems in our homes, you have vacuum systems in industries. So if you create vacuum and break open the vacuum, you can actually smell. And normally what we smell is, if you are using a pump for creating vacuum, you have the oil smell which actually comes in, basically because you have used the oil to create the vacuum. In the same way, if an astronaut goes into outer space, what happens is when they go into space and come back into the ship, their space, their dress, basically their space suit would have been subjected to very high temperatures. So that suit, when they bring it into the satellite, would have a smell which actually is what is perceived to be the smell of outer space there. So it is basically because of, say, normally it is cellulose based material. So cellulose decomposes in the outer space, and that leads to a particular smell. So the answer to what is the space of smell is it is odorless, senseless, spaceless, no smell, because there is nothing there. That is the answer, because it is vacuum, there is no smell for space. Now associated with this is the other question that actually I would link to is my students, and some of them ask, sir, you go to space, you go to moon, and sorry, when you go to the sun, we also normally, even I tell to my students, as you go to the sun, you will get burnt up, you will get fried up as you get closer to the sun. So two questions come related to that area. How hot is it in outer space? That is one question, how hot it is in the outer space. And the other question is how cold it is in the outer space. How, you have two questions there. Now one question is, we expect that it is hot. When is it hot? When you are going towards the sun, and when once you move away from the sun, it would be cold. So estimatedly, the temperature of space is 2.7 Kelvin. So if you talk in terms of Celsius, it is around minus 270 degrees Celsius. Minus 270 degrees Celsius. So just imagine, you have water will become ice at 0 degrees Celsius. We are talking about minus 270 degree Celsius. So just think about that temperature. So it is damn cold. So if you don't have anything and you walk into space, basically your body, your blood, everything in you would actually freeze. So you would actually become a piece of rock because of the coldness in space. So space is cold primarily. But if you are moving towards the direction of the sun, actually what happens is you are going to get the radiations of sun falling into you. So it is hot, but it is very, very hot. See, we estimate that the sun is approximately 6000 Kelvin. Say it is around 6000, you just imagine that it is 6000 degrees Celsius. So it is so hot, and that heat is actually coming to us. So if you put yourselves directly into space with no protective suit, what is going to happen is your blood is going to boil even within a fraction of a second. So simultaneously, what can happen is you put yourself into space without any space suit. your blood is going to boil, and again because of the coldness your blood would actually become solidified and you would die. So ultimately death is the ultimate thing. But the answer to these two questions, so how cold and how hot these spaces, in general space wherever there is no heat, that is you don't have a star whose radiations are coming out, is actually 2.7 Kelvin, whereas when you move towards a star, the temperature actually is very, very high. So this I think also answers to a question, can you survive in the space without any suit? So a space suit is most needed so that you can maintain the temperature to a same uniform. And I think the last question that I would do in this talk here would be, recently, I think day before yesterday, there was I actually came across one WhatsApp message which says that Apollo 11 Neil Armstrong, they actually signed a customs duty certificate when they landed back from moon. So was it true? So typically I actually went back. Actually Apollo 11 landed not on Earth. It did not land on the surface. Actually it landed inside Pacific Ocean. So it was a rocket which fell into the ocean. Now the answer what I was thinking is, okay, so if something falls into the ocean, why should you declare customs, right? So customs declaration is not required for anybody who goes into space and comes back. But in that at that particular point of time, this declaration was said to be given as a joke, because they just wanted to say that NASA just wanted to show as a joke, and that actually now we believe that you need to have a customs declaration. But in general, remember that you don't have to have a customs declaration when you go into space or come back, because as we say, the property of anything which is outer space belongs to no one. So the property that you bring back from space also belongs to no one, and technically you don't have to give a customs declaration. So I think I will finish this talk here. You can definitely mail me more of your questions to my mail.